Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 6-4 rational exponents. Let's begin. Now just like always, let's start off with a little vocabulary and review. Use the terms in the box to complete the diagram, then give examples. So as we can see, we'll have things like irrational numbers, rational numbers, integers, whole numbers, and natural numbers. Well, all of these are a subset of different types of numbers that we will actually work with. And each one of these subsets has a specific rule to them that will actually eliminate a certain amount of numbers. So although numbers are infinite, and each one of these sets are technically infinite, some of them are going to be significantly larger than the other subsets. So we're going to start off with the very first subset, which is always going to be natural numbers. See, natural numbers will be numbers like 1, 2, 3, 4, 5, and so on up. Meaning they're not going to have any decimals, 0 is not going to be a part of it, and there's going to be no negative numbers. The other thing that we used to call natural numbers as well was counting numbers. That's why you always start at 1. The whole numbers is every single value of natural numbers, however, they have one very important number that adds into it, which is going to now include 0. So whole numbers are the exact same thing as natural numbers, but instead of starting at 1, we now start at 0. After whole numbers will come your integers. Integers are all of the non-decimal numbers, but it's going to include the negative as well as the positive. So my example for this one will be -3. Integers will then become rational numbers. If it has a repeating decimal or can be written as a fraction, it's going to be falling into the rational numbers. Therefore, my example will be 3/4. As a fraction, as a rational number. And the very last one will be irrational numbers. Your irrational numbers will be numbers that don't have any sort of pattern, and they'll continuously go on and on and on in the decimal portion. Case in point, the most famous irrational number is going to be pi. And the vocab word for today will be convert. Related words will be like things like conversion and convertible. Definition: to convert is to rewrite or change to another form. So we must circle the expression that shows 3/4 converted to a decimal. Well, the one that is going to be 3/4 that is a decimal form is going to be 0.75. So if we had to use the noun version, that's the conversion, the travelers to Europe calculate the conversion of dollars to euros. The adjective, a convertible sofa is a couch by day and a bed by night. And a verb, to convert fractions to decimals, divide the numerator by the denominator. Problem 1. Simplifying expressions with rational exponents. What is the simplified form of the expression 64 raised to the 1/2 power? Circle the expression that shows 64 to the 1/2 power, rewritten as a radical. So taking a look at this hint, we can kind of notice that our x will stay inside as the radicand, but the denominator of this exponent is going to be considered our index. Now, what they don't really show, because it is a 1, is the fact that the numerator will actually be on the outside as an exponent. So this is really the nth root of x raised to the 1st power. So if I were to do that same exact motion with the 64 raised to the 1/2, my 64 is going to be on the inside as the radicand of that radical. And then we just have to base it off of the exponent is going to be raised to the 1st power, and the index is going to be a 2. And you can kind of notice the exponent is going to be above the index, which it kind of makes sense based off of the fraction. The numerator is above the denominator. However, the 1 being the exponent is implied, and the 2 being the index is also implied. So this will actually turn into the square root of 64. So if I had to solve this one out, the simplified form of 64 raised to the 1/2 power is the exact same answer as the square root of 64, which happens to be 8. Now, the key concept of the rational exponents is essentially what I just showed. If we have a fraction, the denominator is going to be the index, whereas the numerator will be the exponent. Now, you can either write it on the outside like I do, because it kind of makes it so I can see one's on top, one's below. Makes it a little bit easier for me. Or you can absolutely write it on the inside. It's not going to actually change your answer. Now, if I looked at column A and I had to draw a line from each expression in column A to the exponent form in column B, and I see that we have 4 times the cube root of x, That's going to be the exact same thing as the cube root of x raised to the first power. My 1 is above the 3, therefore my fraction needs to be a 1/3. So it should be going to the 4x raised to the 1/3 power. We also have the fourth root of x cubed. That x cubed, I'm going to actually rewrite on the outside. So it's going to turn into the fourth root of x raised to the third power. This allows me to see that the 3 is above the 4, and that's what I should see as the exponent. So it becomes x raised to the 3/4 power. Problem 2. Converting between exponential and radical form. What are the expressions w raised to the negative 5/8 and w raised to the 0.2 in radical form? Is the exponent in w raised to the negative 5/8 in lowest terms? Yes or no? Well, in this case, it is. We can't simplify that 5 divided by 8 any further, although it is a negative, that's perfectly fine. So let's identify the values of a, m, and n for w raised to the negative 5/8 using the rule a, being the base, raised to the m over n power, which is going to equal the nth root of a raised to the mth power. So our a is our base, so it looks like our a is going to equal w. Our m looks like the numerator, so that's going to be a negative 5. So we're just going to attach that negative to the top, the numerator. And then we have an n is going to be the denominator, which happens to be a positive 8. Using your values for a, m, and n to write the w raised to the negative 5/8 in radical form, I'm just going to literally just plug it in straight up. So we are going to have the 8th root of w raised to the negative 5th power. Now, how do we do that same exact conversion with 0.2? So I'm going to rewrite that 0.2 as w raised to the 1/5 power, because 1/5 is 0.2. Identify the values of a, m, and n for w raised to the 0.2 or w raised to the 1/5 power. And that means our a is still going to be w, our m is now going to become 1, and our n is going to be 5. So use the values of a, m, and n to write w raised to the 0.2 power. In radical form, we are going to get the 5th root of w raised to the first power. However, anything raised to the first power is going to be implied, so we don't have to worry about it. Problem 3. Using rational exponents. Kepler's third law of orbital motion states that you can approximate the period p in Earth years it takes a planet to complete one orbit of the Sun using the function p equals d raised to the 3/2 power, where d is the distance in astronomical units, or AU, from the planet to the Sun. Find the approximate length in Earth years of a Venusian year if Venus is 0.72 AUs from the Sun. Complete the problem-solving model below. Well, what we do know is that the distance from Venus to the Sun and the formula for the length of the planet year. What we need to find out is the length of the Venusian year in Earth years, so our plan is use the formula to find the period. So how would we use that formula? Well, basically, we know the distance based off of AUs for Venus from the Sun, so that's 0.72. So we're going to plug 0.72 in for the d value, and then we're just going to raise it to the 3/2 power, and it's going to be roughly about 0.610940259 Earth years. Now let's talk about another key concept, properties of rational exponents. We're going to let m and m represent rational numbers, assuming that no denominator equals 0. If we were to multiply two variables, the exponents are going to add to one another. Therefore, a raised to the m times a raised to the n will equal a raised to the m plus n. If we were to raise an exponent to another exponent, essentially all you're going to do is multiply. So a raised to the m power raised to the nth power will turn into a raised to the m times n. If we have our a times b raised to the m power, that's going to equal the exact same thing as if we were to do a raised to the m times b raised to the m. A raised to the negative m will equal 1 over a raised to the m, so that's just essentially going to flip the equation. So if we raise anything to a negative number, it's going to give you its reciprocal. If we have a raised to the m divided by a raised to the n is very similar to the multiplication, except for just like division is the opposite of multiplication, Adding is going to be the opposite of subtracting. So we need to make sure we do its opposite as well. So if we were to divide these variables, we're going to be subtracting the exponents. But just like the previous one, if we do a divided by b raised to the nth power, it's the exact same thing as a raised to the m divided by b raised to the n. Basically, the very first one, we have g to the third power times g to the fourth. That's the same thing as g to the 3 plus 4, which means that it's going to be g to the seventh. If we end up doing the h raised to the 3 to the fourth power, that's going to be h raised to the 3 times 4 power, which is h raised to the 12th power. If we have 5y raised to the second power, that's the same thing as 5 squared times y squared, which is 25y squared. 2 raised to the negative 6th power is the same thing as 1 over 2 raised to the 6th power, and 2 to the 6th power will give you 64. If we do d raised to the 8th power divided by d raised to the 3rd, that's going to be d raised to the 8th minus 3rd power, which is going to equal d raised to the 5th power. We have a 3 over 4 squared, which means that that's going to be the same thing as 3 squared divided by 4 squared, which will give you 9 divided by 16. So, what is the square root of 3 times the fourth root of 3 in simplest form? Well, like we said before, sometimes it might be a little bit helpful to work it out with fractions instead of paying attention to the radical form. So if I had to rewrite this, that's going to be the exact same thing as 3 raised to the 1/2 power times 3 raised to the 1/4 power. Since the bases, or the numbers, in this case in the radicand portion, but more importantly the bases are the number that are attached to the exponents, are the same, we can use the exact same property as if we were multiplying the same base variables. So we have 3 raised to the 1/2 power times 3 raised to the 1/4 power would turn into 3 raised to the 1/2 plus 1/4 power. So in simplest form, we're going to have 3 raised to the 1/2 plus 1/4, which is going to equal 3 raised to the 3 over 4 power. So in simplest form, that's going to be the same thing as me going the fourth root of 3 cubed, or 3 raised to the 3 over 4 power. Problem 5. Simplifying numbers with rational exponents. What is 32 raised to the negative 3/5 power in simplest form? Solve using 2 different methods, complete each method. So for method 1, it looks like we're going to be taking that 32 and rewriting it as a power of 2. So 2 raised to the 5th power is actually the exact same thing as 32. So if we have 2 raised to the 5th power raised to the negative 3 over 5th power, we can then say that that's the same exact thing as 2 raised to the 5th power times the negative 3 over 5 power, and 5 in that 5 on the denominator will actually end up canceling out, leaving us just with 2 raised to the negative 3 power. Now, 2 raised to the negative 3 will make a, 1 over 2 raised to the 3rd power, and 2 raised to the 3rd power is the exact same thing as 8, so it becomes 1 over 8. So essentially, once again, the negative just will flip the equation. Or we can just automatically flip it out. So that negative flips it to a 1 over 32 raised to the 3/5 power. We then have a 1 divided by the 5th root of 32 raised to the 3rd power. The 5th root of 32 is the same thing as 2 raised to the 3rd power, which will give us 1 divided by 8. So both of these methods will work. It's just basically pick which one you prefer. Me personally, I'm more partial to method 2 than I am method 1. And we finally made it to the lesson check. Let's power through it, guys. So explain why this simplification is incorrect. Well, the radical form of 5 raised to the 1/2 power is going to be the square root of 5. The radical form of 5 times 5 raised to the 1/2 power is going to be 5 square roots of 5. So the radical form of the 25 raised to the 1/2 power is going to be the square root of 25. So if we had to explain why the simplification shown is incorrect, we can basically say that The student incorrectly simplified 5 times 5 raised to the 1/2 power, and the answer should actually be 20 minus 5 square roots of 5. So looking up here, you can kind of notice that although we did multiply out and distribute out that 5, they did 5 times 5, which gives us that 25. That's not the case. You can't do that. That is actually just going to be the 5 square roots of 5, like it says in the equation. So the answer is not going to be 15, it's going to be literally 20 minus 5 square roots of 5. And that is it, everybody. I hope everyone has a wonderful day. Stay out of trouble, don't do anything stupid, and I'll see you guys in the next one.